Alright guys, so in this part I'm going to show you how to use or create some really good IK that's pretty solid here that will function really well for what we want to do. We want to get like kind of a spider leg type of effect. I'm going to show you how to do that here and what kind of IK you can use and how we can activate it. Let me go and get rid of here my heads-up display animation details. Don't really need that. Turn that off for a second. So to be able to, there are some IKs in Maya which are hidden. They're not literally there all the time. They won't show up with every new version. And they're old. They've been around for a while, but they still work pretty well. They're not too shabby. I give you guys a doc week 1, and I can give it to you later on for this coming week, is you can actually go in here and use a Mel script called Create Node IK MC Solver. Now there's another one too you can create called the Spring Solver, and this is in my doc. The Spring Solver allows you to have a spring or accordion effect. But what we want is the MC Solver for the multi-chain, and you get kind of like this, almost like a tentacle type of look to your IK, which is great because that's the kind of movement we're kind of looking for. So we're going to go in here, I'm going to paste it, and then you hit enter. And when you hit enter, you've now activated so that your IK system has that option. You can see it right there, MC Solver 1. Pretty nice. So now what we're going to do is we're going to create this MC Solver. We're going to click on our origin here, our root bone of the finger, click on the end, and you'll now see that when we move this, you get kind of a trippy spider effect. It's actually pretty cool. You can move it pretty much anywhere you want, and it actually has a pretty good type of dimension to it. Look at that. It's almost like a snake. Pretty nice. And if you don't want that, you can just go to the traditional IK. That's up to you. But as you can see, this one works pretty well. It's a pretty darn good job. Handles are huge right here. So once you get that set up the way that you want, you can go in here and just make a controller. Let's move our controller into place. Keep my finger on the V key. And once you got it into place, you want to go ahead and freeze this guy. That lets the animator be able to reposition things. He can do it without having to bust out a calculator. It also can prevent any kind of errors if you add more constraints to a controller. It just gives you a little bit more options. Let's grab our IK. Let's grab our controller. Hit P. So now we have a controller for this, and you can move it wherever you want to move it. Now keep in mind there are limitations because we don't have a lot of geometry, so just be careful how this works. If you want, you could even have it a simple bone system, or in that bone system you just have it so it's like maybe an SDK, so just grab stuff. But remember, when you use SDK, you can limit your movement, and you don't really want to limit your animator's capabilities. This is all a case-by-case type of scenario, and in this case I want this guy to pick up something off this assembly line. So you'll have it so he can grab something, make it functional in some way. You can make it so these two guys have MC Solver, and these two guys maybe have SDK. They just automatically go in, or you could have it so these two guys just have a regular IK system, because you can do that too. So we can go in here, go back to our IK, set it just a regular RP solver, and you still have to be careful with the RP solver because you'll notice he's in a very unique position here, this bone. And if you go past, it's favoring one area, right? Notice that? So when it favors one area, it can flip. Now in this case, when it comes to a robot, that's actually kind of cool. You can actually have them fully rotate. So we're not really limited, but this all depends on what you envision this guy to do. You just got to make sure when he flips, he doesn't run in, his geometry doesn't cross over to the other pieces. So it actually can be kind of cool, although it could be kind of hard to control. Alright, so those are multiple ways to get these done. Again, if you use the SC solver, not SC solver, but the Spring IK, if you use it, you got to be careful because it works like an accordion and it will make these fingers fall in on themselves. So just think it through. Now, if you want to do FK, which is a little bit more ideal, if you do FK controllers, remember you have to treat it just like I showed you in my video and in class, like the FK fingers, where we have controller here and a controller here, each parent constraint to these bones, and what we did was we made a group on the end so that these bones would now actually be parent underneath that group, which is underneath this root. So when you move the whole finger, all the controllers will go with it, but you still have a finite independent control, which is kind of cool, which actually can work pretty well. Alright? Cool, so that's about it, the theory of getting these fingers assembled.